So hey guys, welcome to my YouTube channel. So in this video, we will explore a LangChain based retrieval augmented system that enables effective interaction with PDFs. Walk through the entire process step by step to help you understand how this system works, from setting up the environment to processing and querying PDF documents. By the end of the video, you'll have a clear understanding of the complete flow. So be sure to watch until the end of the video. Yeah, so let's start with the RAG system. So like, what is RAG? So it's a retrieval augmented generation. So RAG is something like, it's a method that combines retrieval based system, we can say. Yeah, so with generation models to provide accurate and relevant response, especially when dealing with vast information sources in RAG. So why RAG is important? So like, we have lots of PDFs. We are interacting with the PDFs. It's not only about the PDF. Like, if we have the lots of some data, so like, we are passing that data to interact with the LLM models, that OpenAI or large language models. So it has to combine retrieval and generation, real-time data access, and contextual response generation, ideal knowledge intensive applications, and easy knowledge updates. So yeah, to moving forward, like, we need pip install by a PDF sentence transformers FAISS CPU. So we are using here the that FAISS embeddings. So let's, like, I have already installed this library, but we can rerun it again. You can also just change the runtime here using that T4 GPU. Well, we are encountering some error here. So yeah, that this pip install, we have to write exclamation mark here. So let's rerun it. So yeah, well, our, yeah, requirements are installing now. So going moving forward, like, let's quickly understand what about this RAG based PDF query system. So the system retrieval augmented generation technique to allow efficient querying of information from a PDF. The process involves extracting text from the document and it converting the text embeddings into embeddings and storing those embeddings in a index for fast retrieval, and then it querying the system to find the most relevant information based on user input. So yeah, let's we can see here, understand the architecture of this flow. So we are extracting the data. So the data is in the form of PDF or any other formats, but we are understanding about the PDF here. So we'll ingest the data in the form of PDF, and the data quickly convert into the chunks. So chunks is basically, we'll understand later. Just understand, like, we have the lot, like, a huge data, that PDF data. So that data we are converting into the smaller words. So that those words are called as a chunk here. And those chunks we are converting into the embedding. So embedding is something like a numpy array. So in those array, we'll store some numerical values of those particular chunks, and then we'll build a semantic index here. Yeah, that semantic index, we build a knowledge base of that. And like, the user is asking some query in the form of the question. That question we also convert into the embeddings, and that embeddings will apply a semantic search using that FAISS we are using in our model here, right? So that particular semantic search will get to the results, and we can also pass that result to the LLM models to generate more creative query, creative output to the user. Well, in this video, we understand about the PDF structure, and will extract the information regarding that user query. So to moving forward, we need to understand if the first process of the flow. So we'll upload the data. So that is the data loader, either in the form of JSON or PDF or anything. So that data is quickly splitting, right? So this is called the chunks that we have discussed here. So these are the text chunks, whatever the data we are ingesting here. So these are the text chunks, and those chunks we are converting into the embeddings. So embeddings are quickly, you can see it is some similar like a numpy array here, right? So we are storing these chunks into some numpy arrays, right? And those numpy, those embeddings we are now like going to store in the some vector database. So this is the store, and these are the vectors. So like we can use like multiple vector databases, right? So yeah, let's moving forward. So these are the requirements which we need: import fits, okay, and the sentence transformers we are using here, the files, as we know that files embeddings we are using, and the import numpy as np is important for to store the embeddings, right? So, and the in sentence transformer model, which is we have this all mini LM L6 v2, right? So let's run it, and we'll see it. Yeah, yeah. So our requirements are get ready now. So we'll, I mean, yeah. So let's download. The meantime, we can download the some PDF. So go to the Google and let's type. Let's suppose I just want to know about the, yeah, the, let's download the Ratan Tata Ji biography. Yeah, let's download it. uh, Searching it, so we can see there are multiple PDFs here. So let's download the first one. Yeah, so just I'm downloading to my system. Yeah, so it said get downloaded, and now, yeah, so it is downloaded now. So let's import that PDF to our Google Colab. Yeah, so we are just importing them. Now our PDF is imported. Now just that PDF save into the variable. So yeah, that I'm storing that variable as a PDF path, right? And yeah, so our PDF is, yeah. So I think it is not uploaded. Let's upload it again. Yeah, it is uploading now. So yeah, our, like we have to just pass our, I mean, PDF path here. Yeah, now it's uploaded. So let me just copy the path and I'm going to paste it here, right? So yeah, let's rerun it again. And yeah, now our requirement is ready. Then PDF is also uploaded here, and then yeah, so the first step is the extract the PDF data, right? Like whatever the PDF we have uploaded, so we have to extract all the PDF data. Like let's suppose in our PDF have some 100 pages, so we have to extract all those 100 pages of data, and that data we have to store in the chunks, right? So these are the chunks that we have to, like the entire PDF we have to convert into the smaller part, like smaller chunks, right? So I took like 300 characters for each chunks. Okay, so let's create a function for the chunks, like so that's the, like I have also included the tags, like you can read it later. I will upload the this dot ipynb file in the comment section, right? So you can download from there. So this is because like breaking the text into chunks help handle the large document efficiently. Why? Because that large document we can convert into that smaller chunks, and smaller chunk size may vary. So I took that 300, but it's up to you. Like you can change it to the 100 or 200 or something. It's up to you. Like it's up to the size of the PDF, right? So we have created a function to extract that data in the form of chunks here, right? So that is PDF path. And yeah, so that text we are going to store in the list. So that empty list we have created, so whatever the chunks we are extracting, so that simply apply a for loop here. And yeah, through the for loop we are going to store that uh, entire text into the chunks of size 300. Yeah, then we are returning that text chunks, right? Yeah, so the next flow is that we have to convert those chunks into the embeddings, and in our system we are using the FAISS embeddings, right? So yeah, so let's understand what exactly embeddings are and why we are using that those embeddings. So embeddings is basically are the vector representation of words or sentences which capture the meaning of context of the text, right? So they allow us to compare text in a way that goes beyond simple keyword matching. So basically embeddings help us to match our document with the user query. So let's suppose we have two sentences that have similar meaning, so we'll have similar embeddings for them, even if they don't contain the same words. In that case, like we have we have the different embeddings. So like this is the reason why the embeddings are important. And what is sentence transformers? So we are using that sentence transformers for the embedding. So transformers, these are the models, right? So that is specifically trained to generate embeddings for sentences or the paragraph that encodes semantic information, right? So these are the, I mean, embeddings which are like used to like store in the encode the semantic information. So we can say these are the key for performing task, which is similarity search. So basically at the end, like we'll apply a similarity search to retrieve the information from the PDF when the user is asking some query, right? So like here what we have done, so the text chunks we have already created before. Okay, so now that function we have made earlier, so yeah, okay, so we are returning that text chunks in that empty list. So we are just extracting those text chunks here, right? And then we are converting those text chunks into the embeddings, right? So we have write that embedding variable here, and we are embedded.encode text chunks. So we are simply applying those text chunks here, and we are converting to tensor. So we don't need the tensor, we need the entire flow of the in the list. So that is I mean, we'll get the embeddings from this variable, this the function which we have written here, right? So yeah, now set up the FAISS index. So understand like why we need that FAISS basically. So let's once we have the embeddings for all the text chunks, right? So that next step is to store them in an index. Okay, so why we need that index? We need to make similarity searches efficient, right? So this is where like FAISS is something like it is a Facebook AI similarity search, right? So it applies a similarity search index. So we'll get like if we have the larger data set, so on larger data set we can store those text chunks, the embeddings into the files to get the similarity search more effective, right? So yeah, I mean, yeah, so I mean there's a complete flow like how the files work. So for that I will make a separate video for that. So in this video, we just understand like how we are going to store that files in our the embeddings in our files model, right? So we have to set the dimensions and the start like that embeddings 0 and the save 0. Like you can change it to the 0 or 1 format of 1 or 1 format, right? But like to see more effective results, we have set it as I mean embeddings 0 and the save is 0 here. Yeah, now the index files dot index and flat L2 and the dimensions we are passing, which we have created here, right? And that we are just adding up those indexes in the numpy array. Okay, so index dot add numpy np array the embeddings as type float, because whatever the embeddings we are creating, these in the form of like we have seen earlier, these are the float values. So we are storing them in the floats, right? Yeah, so here we are storing in the form of floats. Okay, so well, now the next step is, so let's quickly run all the commands. Yeah, we have run this, we have uploaded the PDF, and then we have converted into the chunk. So let's run the chunk command. Okay, now our chunks are ready. And after okay, so now the chunks are ready. Now we'll just, okay, let me just cross it. Yeah, so the chunks are ready here, and now just chunks to convert into the embeddings. We are converting those chunks to the embeddings. Now our embeddings are also ready. Embeddings is nothing, just a numpy array, I mean list of numpy arrays. So yeah, now we will set up our FAISS index to get the similarity search more effective, right? So we have just run the FAISS index command. Yeah, so our chunks are get ready here. And then the, I mean, not the last but second last step, like we have to query the rack system now. Okay, now our almost the 70% requirements are ready. Will now just like use that query the rack system. Okay, so I mean we have the tax chunks indeed with the files earlier. Okay, so the system is ready to handle the user queries. So the process for querying the system involves converting the query into embeddings, right, and using files to find most relevant chunks. Okay, so I mean we have converted the queries to the embedding, sorry, I mean the PDF or to the chunks, and that those chunks we are storing in the embeddings, and we have set up the files index. Okay, so in the files index what we did, we do find the top most similarity chunks, right? So we'll define it as the top k. Okay, so here in the code we can see we are defining a rack query function to find the top k similarity here, right? So to get the top k similarity, like I have set it the value 1. Why? I'll tell you. If I change it to 2, I can change it to 3. So what does it mean? So like if I'm setting at 2 3, so okay, like when the similarity search is applies to the embeddings, I mean the embeddings that the in the PDF, like okay, so we'll get the top 3 similar results there, right, in the form of that list. But if I set it as band, so we'll get the top similarity, okay, with the similarity which comes at the top from that PDF. Okay, so let's quickly run it. Even you can set it as 3 as well. Okay, let's set it at 3 and run the command, so we'll get it. So what we have done here, we have like we have made a function for the rack query. So in that we are passing, like we have made a variable for query embedding. So here we are passing that embedder.encode, and we are passing the query here. Okay, so whatever the query that user will type, so this is the query which will pass to here. Okay, so on this query the entire similarity search will run, right? So from the PDF, so user is typing. So in this flow we understood that user is typing a query. So the PDF which we have ingested before, so that PDF is converting to the chunks, and those chunks will get converted to the embeddings. Why embeddings is important? Because we have to store those embeddings to the vector database. Okay, so on the vector database, so this is the knowledge base, is the vector database basically. So why? Because we have to apply the semantic similarity search. So this is the semantic similarity. So we'll apply the semantic similarity search on here to find the results for the user query. Okay, so we can extend it like on, like after getting the results we can pass to the LLM, large language models, like we can pass to the ChatGPT or any Gemini or any model to get more creative response to the user. But here in this video we are understanding like to extract the information just from the PDF. And if you want more, like we want more creative results, we can pass it to the chat GPT model. So it's just the 2 lines of code. Okay, if we add this chat GPT to our user query output, right? So here we are passing, like we are getting the results in the form of chunks. Okay, so we returning the results to this function, that rack query function. And here now at the end, like we have to pass that the query. Okay, so like I have already made, we have made the query for like date of birth, place of Ratanji Tata. So okay, so let's run it and we'll get the output is something. Okay, we are getting some error. Let's quickly okay, so this error is something can't convert CUDA device type tensor to numpy user. Okay, okay, host memory first. Okay, let yeah, so well, I think that T4 GPU is not working. All right, so let's check it. Okay, but I have said this save is okay. No problem. We can use our CPU here. So for that, we can just write it at wherever embeddings. Sorry, the embedding, and we can use the CPU for that. Right. Again, we are passing that query embedding. Okay, dot CPU quickly, right? So we can pass it, and also we have to pass that CPU as well here. Okay, because it is like okay, all right. So now we can try run it. run the command and we'll see the result. Okay, it ran, and let's run our example query. Okay, so we are getting, okay, so yeah, the result is something like, so yeah, Ratan Naval Tata was born on December 28th, 1937 as the son of Naval Tata. So he was a son of Jamshedji Tata, the founder of Tata Group. Okay, so we can pass our user query, and it will get, retrieve the information from the PDF basically. So let's pass like, okay, when he found it, when he was the chairperson son of Tata Group. Okay, let's run it. Okay, so in 1991, named Ratan Tata, okay, successor, so admits facing criticism for leaking experience. Okay, so we'll get the information regarding this. He was appointed the chairman of Tata Group in 1991. Right, so let's see how our PDF looks like. So this is the PDF. So yeah, in early life we see that Ratan Naval Tata, okay, the born in 28 1937. Okay, let's see some other query. Okay, regarding the Tata Nano, let's type a query related to the Tata Nano. He came up with the idea Tata Nano car. Okay, okay, let's type a query regarding the Tata Nano. Okay, Nano. Okay, so okay, when he get the idea about Tata Nano, right? Let's quickly run it. Okay, so we get it. Okay, so he came up with the idea of Tata Nano car with the during the Tata as a chairperson of Tata Group. Okay, so we'll get about it. Okay, so and also we'll get some other information as well, that the Tata, so we are extracting that information basically based on that rack system. So let me recap of this flow. So yeah, we have to install our the requirement, that the pip install, that the sentence transformers, and the py-pdf and FAISS CPU, right? So here, what this is the flow. We are ingesting the PDF, converting to the chunks, and those chunks we are converting to the embeddings, and for the embeddings we are using the sentence transformers, right? And those embeddings we are going to store in the vector database for the similarity search. Okay, so we are building that semantic search on that, right? So whatever the user will type a query, that query also will get convert to the embeddings. Okay, because we are computing in the numerical arrays, right? So that arrays will apply a semantic search using the FAISS system, right? That FAISS, why FAISS is important? Because FAISS just boost up the similarity search. Okay, so we'll get the output on that. Okay, we can also extend this model to, we can pass it to the chat gpt or any LLM model, large language model, right? So this is the how we are setting up our requirements, that load PDF, converting to the split, and these are chunks, then embeddings, then the we are going to store in the any vector database we can use. Okay, that like there are several databases like Chroma DB, so and okay, so OpenAI databases as well, so we can store any DB as well. So this is the, we are uploading our PDF and we are using the sentence transformers right here. So yeah, so yeah, that converting to the text chunks, and text chunks going to store in the embeddings, embedding using that FAISS index, right? So this is very important, like it boosts up our similarity search here. Okay, and then we just query our rack system, and it's up to us. Like I have set it the k3 here, and if I set the k1 here, we'll only get the one response in our output, and like whatever the query we are typing, we'll get only the one response output. Okay, so this is something the thing which we can get in the output form. So yeah, I mean, this was the overall flow. I'm going to attach a PDF file here as well, this about this complete flow of this video, right? So that's the, sorry, yeah, here's a complete explanation of the flow, and how you can make your own in PDF information extractor, so that you can use using that LLM model, right? And the files and the in sentence transformer embeddings. Okay, so yeah, thank you everyone. If you like my flow and the video, please like and subscribe my channel, and I will update regarding the similar video informations in future.